All right, next one. So 6-17 theorem says if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. Okay, so if the one diagonal of a parallelogram bisects a pair of opposite angles, so if a diagonal bisects a pair of opposite angles, then that parallelogram is a rhombus. All right, so let's prove it. So ABCD is a parallelogram. And we also know that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, right? So so these two angles are congruent, angle 1 and 2, right? Meaning that DB bisects angle ABC, and then angle 3 is congruent to angle 4. So therefore, BD also bisects ADC, right? So in other words, this one diagonal bisects bisects a pair of opposite angles, right? And that's all given. All right, and so now we can say, okay, by the reflexive property, dB is congruent to itself, right? And that's enough to give us, so reflexive prop, and that's enough to give us angle, side, angle, angle, side, angle, right? So we can say that those two triangles are congruent. We can say that D, triangle DAB is congruent to triangle DCB, right? And right, because 3 and 4 go together, so that means D corresponds with itself, or the respective D's correspond with one another, I should say. And so that's angle, side, angle. All right, and then step 4, now we can say, okay, well, side AB must be congruent to side BC, right? Because those correspond. So AB and BC, right? So AB must be congruent to BC, and DC must be congruent to AD. So DC must be congruent to AD. And that's all true by CPCTC. Okay. All right. Now the other thing we know, since this is a parallelogram, we know that opposite sides are congruent, right? So I can say that AB is actually congruent to DC, right? So AB is congruent to DC. And we can say that AD is congruent to BC, right? Because those are opposite, and we have a parallelogram congruent to BC. And that's because if it's a parallelogram, then opposite sides are congruent. Okay. All right. And so by the transitive property now, if AB equals BC and BC equals AD, then that means AB must be congruent to AD, right? So AB must be congruent to AD, right? And BC must be congruent to DC, right? Because they're both congruent to AD, right? So that's by transitive property of congruence. And we can really just take out this, we can just say that they're all congruent to one another, right, by transitive property, because if you look at all these, we've said that, right? AD is congruent to BC, so we can just put that congruent in the middle there. And then now that we know that all the sides are congruent, that means that this shape is a rhombus, right? ABCD is a rhombus by definition of a rhombus.